So here is the practice test that I disseminated a few days ago. Why don't we go through the questions one at a time? And please feel free to stop me whenever you have questions. So let's begin with question number one about a zero coupon bond. I'm going to put this on the whiteboard to make it easier for you to follow. So remember that for a zero coupon bond, there is no explicit interest paid. Instead, the bond will pay off at its face value at the end of its maturity. So for example, we have a bond, a zero coupon bond with a face value of 1,000. Okay, so far. So that we are told that the zero coupon bond in this case has an implied interest rate of 100%. So in other words, the bond is paying off for the lender, the purchaser, by the face value minus the initial price of the loan. So for example, not for this particular problem, but in general, suppose that the bond sells this is $500. To use the lender. So you pay 500. After 1 year, you collect $1,000, the face value of the bond. So the implied interest in this case is 1,000 minus 500 or 500. Since this is gain by hanging on to the bond until it matures and pays off. Okay, so that's one part of the problem. The other part deals with present value. So remember that present value is the value today of a future payment. So, for example, the person should have $1,000 in your savings account. And the interest rate is 10%. Or expressed as a fraction, 0.1. On the principal in your account, you will earn 10% interest after 1 year. Or $1,100 overall after 1 year. Then we will say that the present value of $1,100 to be received after 1 year given an interest rate of 10%. It's $1,000. Because if you put $1,000 in your account today, you will receive $1,100 after 1 year. Okay, on the definition of present value. Okay, so as you remember, our formula for present value consists of the true value of coded A divided by 1 plus R to the power n. The A in our example is 1100, or it's the state of 10%. Then A is the number of years over which you are accumulating money in your account. In our example, N is equal to 1. So we have a present value of 1100 divided by 1.1, or a present value of $1,000 overall. Okay, now in question number 1, the interest rate implied is 100%. But be careful in using this in present value. In present value, we express the interest rate as a fraction, not in percentage points. For example, for an interest rate of 10%, we will use the fraction 0.1. In question 1, express the interest rate as 1. The same as 100%. So the present value in the problem is the $1,000 to be received after 1 year divided by 1 plus the interest rate. But the interest rate is 100% or 1. So the present value is $500 in this case. So I will give you a moment to look at all of this and raise any questions that you have now. I will also save it and send you a screenshot. Okay, so this is an interesting result because the seller of the bond collects $500 and then pays the lender after 1 year the face value of $1,000. So in this case, present value is the initial price of the zero coupon bond. The implied interest equals the initial bond price of the amount of money that the borrower is collecting. Because the interest rate is 100%. And that I think it's all that we have to say about the first problem, unless you have questions. Okay, so let's move on now of the problem number 2. So now we have a conventional bond, a coupon bond that pays $100 of interest each year and has a face value of $500. So we're going to think about the rate of return on the first year of the bond as well as the annual coupon rate. Our bond pays $500 in interest each year. This payment is sometimes called a coupon payment. But because historically, when you wanted to collect interest on the bond, you turn in a coupon, took it off the bond, a coupon, and send it to their bond children, who would then show you continue the interest rate. on this bond, the interest payment is fixed. It never changes. Even if you sell the bond on the open market, the coupon still would be $500. So just an interesting historical fact, that's all. Okay, so what is the annual interest rate, the coupon rate on the bond? It is the annual interest payment divided by the initial price of the bond. So if the bond price is 500, and the interest payment is 100, then the annual coupon rate for the first year is 100 divided by the price of 500, or 50% of 0.2. So in this case, the initial price is 400. And then after 1 year, the price increases to 500. And we've got to find the overall rate of return to the bond for the first year. So we'll add those facts to our example here. So to answer this question, let's think very generally about the rate of return on the bond after 1 year. The rate of return reflects the interest rate, the coupon rate of plus any money that you can make for selling the bond after 1 year. So the rate of return looks like this. Here is the coupon payment that you will earn in the first year. And then let's add to that the amount of money that you make for selling the bond after 1 year. The price in year 2 minus the price that you have already paid in year 1. So there is a technical gain or loss. And then to express all of this as a rate, we will divide the initial price of the bond. So once you understand the formula, that the problem is very easy enough to solve. The coupon payment in this case is $100. So let's substitute 100 for the coupon payment. And then we sell the bond for 500 for a gain of $100 over the year. That is 500 minus 400, or P2 minus P1. And then we will relate all of that to the initial price of the bond, $400. So the rate of return taking into account both the interest and the principal change is 200 divided by 400, or 50%. I will pause now to give you a chance to look at those notes in case you have questions. Okay, good. Another way that we can express the rate of return is very intuitive. The rate of return is equal to the coupon payment divided by the initial price of the bond, plus the capital gain. Also divided by the initial price. So in other words, the rate of return as the coupon rate, the rate of the amount of money that you make by collecting interest of plus the capital gain. So for a year, you make money on the bond by collecting interest and then to pay to sell the bond on the market. So let's take a look at these two components. The coupon rate is 100, the interest after 1 year, divided by the initial price of the bond of 400. And that's a rate of 25%. And then the rate of capital gain is the $100 that you make by selling the bond. Again, expressed relative to the initial price of the bond, also 25%. So note that the overall rate of return is the sum of the coupon rate and the change in the capital gain. In this case, it's 50%, or 55 plus 55. Any questions about problem number 2? So I will give you a moment to look at those notes, and then we will move on to problem number 3. I will also send you the screenshots of the session and also post to the Moodle page of the recorded lecture at the end of class. Any questions about problem number 2? Okay, good. Question 3 is again a present value problem. we received $1,100 after 1 year, given an interest rate of 10%. And you have to fund present value. Remember, our formula for present value is A, that the current value divided by 1 plus the interest rate to the power n, where n is the number of years of maturity. In this case, the current value after 1 year is $1,100. And the interest rate R is 10%. And then finally, we have only 1 year, so n is equal to 1. Thus, the present value is 1,100 divided by 1 plus 0.1 to the power of 1, or $1,000. So in other words, if you took $1,000 in a savings account today, you will accumulate to $1,100 after 1 year. So $1,000 is the present value in the sense that with that money today, he can have $1,100 next year. It is the value of the future payment. Now look, after 1 year, the current value of the savings account is $1,100. Because next year, 2023, we will have $1,100. This is not the same as present value. Present value is the value today of the future payment. Current value is the current worth of that account. The current in this case means the year 2023. Okay, so far on problem number 3. So this problem, I think, is truly straightforward. But let me go back to the whiteboard and give you a chance to look at the notes before we move on. Okay, so far.
What question about fifth and fourth? I, I don't understand.
Go ahead. What is your question?
5 and 6. I don't understand.
Problem number 6.
Yes.
Can you see that? Question number 6.
Yes.
Okay. So we have expected deflation. That is, people expect prices on average to go down, not up but down in this case. Okay, so in the bond market, we have buyers and lenders. Buyers will sell bonds. I want to raise $1,000, so I will sell a bond to you, a piece of paper, in exchange for $1,000. And lenders will buy the bonds. So you buy the bond, and then you will collect interest from me year to year until the bond matures. So let's think about how deflation might affect dollars and lenders. If prices are turning down in perfect storm, let's say, then 1 million tangy will buy more goods next year than today. So, for example, suppose that the price of a computer, a supercomputer, is 1 million tenge today, and 500,000 tenge next year. Then 1 million tenge will buy those computers this year, the 2 computers next year. So the vendor would be happy to run up to above 1 million tenge today. In exchange for getting the 1 million tenge back next year. Because he is getting paid back in stronger tenge than he had provided. But making the loan, the lender gives up basically 1 computer today, but needs 2 computers next year. So the purchasing power of this money is rising. And so lenders like deflation. Now, what about the borrower? Well, the borrower borrows 1 million tenge today. And can buy 1 computer today. But next year, he must pay back 1 million tenge, never mind the interest. And that amount of money next year could have bought 2 computers. So the borrower is losing on the transaction by the equivalent of one computer. Farmers hate deflation. Because they have to pay back in stronger taking than they had initially borrowed. I will give you a moment to look at the notes. Okay, so far. So now let's take a look at the bond market and how deflation will affect it. We can, on the vertical axis, we can express both the price and the interest rate on the bond. Remember that bond prices and interest rates move in opposite directions. If bond prices rise, interest rates will fall. Okay, so here is the demand for bonds. Creditors demand bonds. And then here's the supply of bonds. Borrowers sell bonds for money today. we have just seen that lenders love deflation. So when prices are expected to fall, people want to buy more bonds at any given price. So the demand function shifts to the right. But boys, dollars hate deflation, and so people put back on supply if they expect a prices to fall next year. So the supply function shifts to the left. So both demand and supply change. So let's take a look at what happens overall. If bond prices will rise because of demand has increased for a reduced supply. Since bond prices will rise, interest rates will fall. Remember, there is this inverse relationship. So, but without more information about the relative shifts of the functions, we're not sure what will happen to volume of the number of bonds sold. Demand rises, it pushes up the number of bonds sold. The supply falls, it pushes down the number of bonds sold. So in the graph, it looks as if garden does not change very much, but that's because of the way that I do the two functions. I could have drawn them this way. I could have considered a very small increase in demand. And a very large decrease in supply. So in this case, there is a large decrease in the number of bonds. We go from point A, the initial equilibrium, we'll call that A. To point B right over here. So in this case, there is a large reduction in the number of bonds sold. From D1 to D2. And the price rises. I will pause to give you a chance to look at the notes. Okay, so far. There is a way that you can keep track of the changes in the market when both supply and demand are shifting. You can do this by drawing up a table. To get the impact on prices, interest rates, and quantity. So this suppose that demand rises and nothing else changes, only demand. In that case, the price will rise and quantity will rise as well. And then the interest rate drops because of the inverse relationship with prices. Likewise, if supply falls and nothing else changes, then price again will rise. The quantity that will fall. So overall, we can be confident that prices will rise and interest rates will fall. But we're not sure what will happen to quantity. So if you ever become confused, try turning up the table and consider each shift one at a time. Any other questions about that problem? That's a good question. The two ways. Thank you. So that leaves us with questions 5 and 6. This, by the way, is another question about deflation. we have the real interest rate is 4%, which doesn't way into a realistic figure. And the rate of effective inflation is minus 4%. That is, we expect prices to fall rather than rise. And we look to find the nominal interest rate that is the interest rate in terms of trading rather than goods. Okay, so remember this is inflation. The nominal interest rate is equal to the real interest rate. Plus the effective rate of inflation. So the idea is that if banks know that prices are going to rise next year, they want to be compensated for that inflation because they're going to get paid back in cheaper dollars than they had provided. Okay, the nominal rate is the rate that is actually charged on the bank loan in terms of taking. So we have a real interest rate of 4%, and then a rate of inflation of minus 4%. So the nominal interest rate in this case is zero. Which is interesting because this has been very common around the world for several years. Interest rates are very, very low. Especially into 10. I will give it a moment to look at the notes. Questions about the problem? Other questions?
No questions.
Okay,